So let's talk about absolute value today. What is the definition of absolute value? What does it mean? Anyone know? It means a number's distance from 0. So if you think about a number line, you have 0 here in the middle, and absolute value doesn't care what direction we go in. It's saying how far away are we from 0. So if I say the absolute value of 3 and I use these parallel lines next to 3, that's the symbol that means absolute value. How far away from 0 is 3? It's actually 3 units, right, away. And then if I say the absolute value of -3, how far away from 0 is that? Also 3. So the absolute value is always positive because the distance can't be negative. In fact, the people who decided that, and they showed us in that movie, you remember the, what is it? Ferris Bueller's Day Off. Do you remember that movie? Anyway, they go on a joyride in the fancy car, and then what do they try to do? At the end of the movie, they try to prop the car up and put the car in reverse, thinking that's going to take miles off the car. Does that work? No, because distance doesn't care which direction you go in. Distance is always positive. So the distance will always be positive. So we can look at this in graphic form. Here we have f of x equals x. This is the same thing as y equals x. And if we were going to make a table of values, x, y, you might have -3. If you plug in -3, you get -3. -2, -2, -1, -1. 0, 1, or 0, 1, 0, 0, 1, 1. You see, that's y equals x, right? The slope is 1, the y-intercept is 0, and that's just a linear equation. Now, if we try to graph y equals the absolute value of x, let's look and see what happens. So if I plug in a negative, oops, this is my x, this is my y on a table. If I plug in -3, what's the absolute value? We just said the absolute value of -3 is what? Is 3. What's the absolute value of -2? Absolute value of -1 and 0? 1. 1 is 1. Yeah. Oops, the 0. Sorry, 0, 0. I just did that same thing again, right? 0, 1. You're like, where is she getting that from? Absolute value of 0 is 0. Sorry, you were right. I was wrong. And then it goes positive. So you start to see this shape emerge. It looks a little bit like a parabola, but it doesn't have any rounded turns. It's just 2 straight lines going both positive. So here we could say that the domain is all real numbers. What would the range be? Right, from 0 to positive infinity, right, would be the range. And you had a question? Did you?
So with the other table, right?
Yes.
Like 3 and 2, how do you figure those out?
Well, because I see what you're saying. So I'm making a table. If I'm plugging in the numbers, there's nothing to do to that number, right? Because there's an implied multiply by 1 plus 0, which we actually call that 1. When we multiply by 1, it doesn't change the value. That's the slope of 1. So that's the identity property of multiplication. If I'm adding 0, it also doesn't change the value. That 0 is the y-intercept, and that's the identity property of addition, because if I add 0, it doesn't change its identity, right? It stays the same. If we had more going on, like here we have 3x minus 6. F of x equals 3x minus 6. So if I was going to make a table of values here, I would have more to do to the x that I plug in. So let's say I plug in x equals 0. What would f of x or y equal? If we plug it in here, so I go f of 0, -6, good. And that we call the y-intercept, right? So that -6 is the y-intercept. What do we call the 3 that's in front of the x, the coefficient? We call it the slope. Yes, and this has a slope of 3. If I plug in 1, I would go, see how it's more complicated? I have to go 3 times 1 is 3, -3. Good. And there's 1, -3. These are the points, the ordered pair that make up the line. So we can see that this is a linear equation. It has a slope. It has a y-intercept. I mean, this has a slope and a y-intercept as well, the one above. And then over here, if we do this with the absolute value, because if I were to plug these points in, x and y, if I plug in 0, I'm going to go 0 times 3, and you said that was -6, but I'm going to take the absolute value, and that becomes a +6. So that's why it's going, yeah, you're right. If you're taking the absolute value of a negative, it becomes a positive. Now, if you take the absolute value of a positive, does it become a negative? No. The absolute value is always going to be equal to a positive number. So again, if I do 1, I plug in 1, I get 3 times 1 is 3 -6, that's -3, but instead we get +3 because we're taking the absolute value of it. So that's why you see this point right here. You have 0, 6 is the y-intercept, and you have 1, 3. Okay, and that's what the absolute value is always going to look like. In fact, I wanted to just show you really quickly how I can type this in on Desmos. So I put up my Desmos on my phone because I got the app for that, right? And actually it does have that symbol for absolute value. So you see that those parallel lines around the A mean absolute value. And if I just pressed that and then the X and then I pressed it again, and you can see that same graph that we have here, right? And if I want to do the table of values, I can click on the gear icon and press table, and you can see that it's plugging those similar values of X in, and it's giving you those positive values of Y. Yes, question? I might have a take-home portion of the final, in which case you would be able to, but you can't really use technology because you can't use a phone on your final. Yeah, because we'd be able to access the internet. But you can use a calculator for part 2. If I do ask you to do problems on Desmos, then I'll make that portion take home. Okay? Okay, so the absolute value functions are usually described as a V-shaped graph, and the tip of the V is called the vertex. Oh, that's very similar to what we learned about quadratics, right? So in this example, we can solve an absolute value equation. We can actually solve it graphically. And the way we do this, if we're going to solve graphically, we start by taking the first side and we write y equals the absolute value of x, and that's this graph right here. Okay, I didn't print it in color, but that's the y equals the absolute value of x, which we had just graphed above. Now, if I want to solve this graphically, what I do is I take the second side and I write y equals 3. And what do you know about the equation y equals 3? It's a line. What kind of line? Yeah, it's a straight line. It's also a horizontal line. So y equals 3 is this line right here. And what we're wanting to determine is what are the points of intersection. So the points of intersection are, yes, this point right here is -3, 3. This point over here is +3, 3. That's because if I plug in +3, the absolute value of 3 is 3, and the absolute value of -3, what's that? Also 3, right? So that's where these two lines, these two different equations, the graphs of the equations, I should say, this is where they intersect. And the points of intersection are the solution. So the solution set is 3 and -3. That is what satisfies the equation. Okay, so keep in mind here that there's a huge difference between the expression, the absolute value 3, and the equation x equals the absolute value of 3. Oops, did I say negative? The expression absolute value of 3 versus x equals the absolute value of 3. The expression the absolute value of 3 means that it's equal to 3, which is the distance from 0 to 3 on the number line, as we talked about before. The equation x equals the absolute value of 3 is asking you to find all of the x values whose distance from 0 is 3. And there are two such numbers, 3 and negative 3. So that's why we're saying x could have been either a positive or a negative 3. Does that sort of make sense? Okay. All right. So let's go ahead and turn the page onto another problem. So here's another example. We have the absolute value of x minus 3 equals 4. To solve this graphically, we graphed y equals the absolute value of x minus 3, and we could do that with a table of values. We could do that with Desmos. So we're graphing that, and it's going to most likely be a V shape when we graph that. So that's the first thing we do. Then the second one, we set up y equals 4 because that's the second side of the equation. So we have y equals the first side, and then y equals the second side. So we're setting up two different equations. We're graphing them. We're finding the points of intersection. And then you can see that they cross at -1 and 7. And if you were to take -1 and plug it in, let's see if it works. So we can always check it. If we weren't sure if we graphed it correctly, if we weren't sure if these solutions actually worked, we could always plug them in. So a check would look like -1 minus 3, the absolute value. Is that equal to 4? We get the absolute value of what? -4. Is that equal to 4? Yeah. And then we can do the same thing. So we get 4 equals 4, and that worked out. We can do the exact same thing for 7. So what we do here is we take and we plug in 7. We have the absolute value of 7 minus 3. Is it equal to 4? We get absolute value of 4 equals 4, and 4 is equal to 4. Now, what if we wanted to solve this algebraically? To solve it algebraically, we could say, well, if I took away the absolute value signs, this could have been a positive 4 or it could have been a negative 4. So to solve, we take off, let's say we remove the absolute value symbols, and then we use the positive and negative value of whatever it's equal to. So I'll just show you an example. We go x minus 3, I've removed the absolute value, equals 4, or x minus 3 equals what? Would you say? -4, right? So we're going to do the positive and the negative, and now I can solve for x. So how would I get x by itself here? Add 3 to both sides, right? I get x equals 7. That was one of our solutions. And then what would I do to solve for x here? Add 3, and we get x equals -1. And that was our second solution. So I've already shown the check, but if I solved algebraically, I could put my two solutions in set notation, and then I would always want to check, because we don't want to have nuclear meltdowns, right? We're going to check our work, okay? So this is telling us right here the equation property of absolute value. For each number of x and each number of k such that k is greater than 0, we can say the absolute value of k, or absolute value of x, is equal to a number k. Then x would equal k, or x would equal -k. Okay? If k is less than 0, what kind of numbers are less than 0? Negative numbers, exactly. If k is negative, in other words, then if you say the absolute value of x is equal to k, that will not have a solution, right? Imagine for a minute I said that this absolute value equation, imagine I said that the absolute value of x minus 3 is equal to -4, or actually even -1. Let's just do -1. -1 is all the way down here. Does the absolute value equation cross with -1? No, because absolute value cannot be equal to a negative. So right away, you could know there would be no solution to an equation like that. Okay, let's go ahead and look at two other examples then. So for example 3, we're going to use the above equation property of absolute values to solve each of the following algebraically. Then we're going to write the solutions in set notation, and we're going to check, because we have OCD about math, and that's okay. That's the one area in life it's a good thing. So what would we do to solve this? Well, same thing we did above. So we start with x plus 9 equals 18. That's one equation. Or what else? You would keep whatever is inside the absolute value the exact same, and you're going to set it equal to the positive or the negative. Because remember that whatever was inside could have been positive to give us 18, or could have been negative 18, right? So now we're going to set it to the positive and the negative, just like this is what this translates to above in algebra speak. And then what do we do to solve for x? What should I do here? Essentially, yeah. X equals 9, so that's one solution. And most people will forget to do the second one, but that's the same. We have to also check both because we can have two different answers. So we go minus 9, minus 9. What could x also equal? Negative 27, is that what you said? And then we would use set notation, 9 and negative 27, and then to check it, we can plug it back in. So our check would look like absolute value of 9 plus 9, is that 18? And is it? Yeah, that's 18 equals 18. Then we have the absolute value of negative 27 plus 9, is that equal to 18? And we get absolute value of negative 18, which is equal to 18. That's true because 18 equals 18. Absolute value is positive. Now, anytime you have an absolute value equation and there's more going on than the absolute value, you want to, step 1, what do you think you would want to do first? Yes, you want to isolate. So step 1 would be to isolate the absolute value. So you guys said I should add 2 to both sides. I get the absolute value of 3x minus 9 equals 12. And now what should I do to set this one up to solve? Yeah. 3x minus 9 equals positive 12, or 3x minus 9 equals negative 12. So you're going to solve both. You have 1, 2, solve both. And then at the end, you'll want to also check. So because this video is going a little long, I'm going to allow you guys to do these. And then what I want you to do is on the very next page, there are several problems that I would like you to try in groups. Notice here, to isolate the absolute value, what would you need to do to isolate the absolute value here? Let's just do that really quick so that everyone's ready on that page. You would first subtract 3 from both sides. You get 2 times 9 minus 2x equals 2. Now that 2, you cannot distribute the 2 in because these are not parentheses. So what do I still need to do next in order to isolate the absolute value? What would be the next step? Yeah, how do you remove it? You just get rid of it? Do you add it? Do you subtract it? Divide. Why divide? Yes, divide the 2 on both sides. You get the absolute value of 9 minus 2x equals 1. Then you set that up. You have 9 minus 2x equals positive 1, or 9 minus 2x equals negative 1. So you're going to solve both of those, right? You set it equal to the positive and negative. Notice the signs inside the absolute value do not change. So that's something to remember, okay? So let's have you guys practice some of those problems together.